All right, class. We're going to go through this just so you can see how it all works. If you have questions or you still have parts that confuse you, please come in and see me before you take your test. Or if it's a quick question, you can ask me right before your test. When you look at number 1, it says change 220 degrees to a radian measure in terms of pi. When we change something in terms of radians, you multiply by pi over 180 degrees. Then you just type 220 times pi over 180, and you end up with 11 over 9 pi, which in our case would be B for number 1. Most likely on your test, you will be given one that's converting to radians, so make sure you do know that conversion. When you get to 2 and 3, I will have these equations written up on the board. I do not expect you to have them memorized. On number 2, they want you to, for a circle of radius 6 feet, find the arc length S subtended by the central angle. So arc length would be S equals R times theta. But remember, your theta, or your central angle, has to be in terms of radians. So they told you this was 51 degrees, so you need to multiply that by pi over 180. When you do that, you end up with, I end up with 17, okay, this ends up being 17 pi over 60. So when I go to find my answer, I end up with 6 times 17 pi over 60, which would end up being 17 pi over 10 feet, which is D. Okay, the biggest thing there is making sure you're in terms of radians. Again, I will give you that equation, and I will give you the equation you need for number 3. Number 3 says find the area of a sector with the central angle of 200 degrees and the radius of 18.9 millimeters, round to the nearest tenth. If they want sector, the area of a sector, it's 1/2 r squared times theta. Again, theta has to be in terms of radians, so we're going to convert 200 degrees to radians. So you're going to multiply by pi over 180. You end up with 10 pi over 9. So if I go 1/2 times 18.9 squared times 10 pi over 9 and type that all into a calculator, I end up with 623.4 millimeters squared. Again, it is D. When you get to number 4, it says find the amplitude, period, phase shift of that equation. If you notice, the phase shift has been whited out, and that's because phase shift can have some additional pieces that we didn't discuss. You should be able to figure out the answer just based off the amplitude and the period. So remember, your amplitude is the absolute value of this front number, so the absolute value of -6, which is just 6. If I look, there's only one choice that gives me an amplitude of 6. So just by that, I know this answer is A. If I want to know the period, though, you go 2 pi divided by the number with your x, because that's your B. So it would be 2 pi over 5, which is also part of A. Number 5 says, write an equation of the cosine function with an amplitude of 3 and a period of 8 pi. So first off, if they want a cosine function, you're going to start by writing cosine. Remember, amplitude, when they give you that, is always in positive form, but we're not sure if it should be positive or negative. So you're going to put plus or minus 3 in front. So that automatically puts you either at A or B. So the part we need to figure out is what the number with the x should be. So to do that, that's where the period comes in. Your period equation is 2 pi over B, and we know our period is 8 pi. And you need to solve this guy out. So you're going to times by B. So you get 2 pi equals 8 pi times B. And then you're going to divide by 8 pi. So the pi's cancel. 2 over 8 was simplified to 1/4. So the number with your variable should be 1/4, which means your answer should be A. Number 6 says, write an equation of the cosine function again. So we're going to write cosine. That has the given amplitude, period, phase shift, and vertical shift. Again, phase shift will be taken out, but you should be able to figure it out based off of the amplitude, period, and vertical shift. First off, your amplitude is 4, so this should be plus or minus 4. we need something with x, and you have a vertical shift, so you should have -4 outside of parentheses. So if I look at my choices, I'm either B or C, because those are the only two that have a -4 at the end. So again, I'm going to kind of have to do like I did in number 5, and I'm going to go 2 pi over B equals, and I can put this pi up on top and make that 2 pi over 3. Well, the tops are already the same, so the bottoms are going to have to be the same, which means the number with my x should just be 3. That means your answer would end up being C on that one. Okay, make sure you know the period equation because I won't give that to you. So make sure you know that period equation and the conversion factor for radians. When it comes to the next 3, they want you to find the inverse, which is what we did in the last lesson. So remember, when you go to find an inverse, you're going to switch x and y, and you're going to solve it for y. Now on number 7, your 2y is attached to the cosine. So first thing we need to do is get rid of that by doing the inverse function. So I have cosine inverse of x equals 2y. I need y by itself, so I'm going to divide the whole thing by 2. Well, if you look at your answer choices, this is not an answer choice. And we talked about this the other day. It can also be written in this form. And that is an answer choice. Specifically, that is answer choice D. Okay, make sure you pick the one that has the half in front. Not just x over 2, because it's the whole function divided by 2, not just the x. When you get to number 8, you have a number being added in front of your trig function. And before you can get rid of the trig function, it has to be by itself. So the first thing you're going to do on this one is minus pi over 4 on both sides. Well, technically, you'd switch x and y first. So you get this. Now that sign is by itself on this side, then you do the trig function to get rid of it. So this would be sine inverse. When you do that, you took sine inverse of an entire side. So this whole left side should be in a parenthesis. So if I look at my answer choices, that would be choice C. Now they used arc sine instead of sine inverse, but just remember that those are interchangeable. The last one of these has, and we didn't do one completely like this, but we did quite a few. On this one, it's a trig function and a parenthesis that's attached to it. So you need to get rid of the trig function first by doing cosine of both sides. So you're going to do cosine x equals y minus pi if I switch x and y as well. And then I just add pi. You'll see them a lot of times added at the front rather than the end, and we talked a little bit about that. They do that to try and avoid confusion that it's not with the trig function. So if I look at this one, that is also choice C. Number 10 asks you to evaluate, and when they ask you to evaluate on number 10 and on number 11, you're going to simply type it all into a calculator. When you type this in, I know you get 0.9 something, okay? It's positive, but the calculator does not come out with the answer choices that you have. So we know it's positive, so it can't be A or B. So to determine your answer, type C into the calculator. If it gives you the same decimal, then that's your answer. If it doesn't, then type D in, and it should give you the same decimal. In this case on number 10, if you type C in, which is 11 over the square root of 130, that does give you the same answer as your decimal. So that's just typing in a calculator and getting out an answer. When you do number 11, you're going to just type that directly into a calculator. Now, for this entire test, your calculator should be in radian mode. So just make sure it stays in radians the whole time. When you do number 11 and you type it into a calculator, you end up with C. If you need help typing something into a calculator, you might need to come in and ask, or ask me before you take your test, so that we're not trying to figure that out during the test. On number 12, this is the start of your short answer ones. You only have 4 short answers. On number 12, they want you to state the amplitude and period of the function. So here's the function. The amplitude is the absolute value of the front number, so that's just 2. And the period is 2 pi divided by the number with your theta. So that would be 3/2. Type that in a calculator or simplify it, and it becomes 4 pi over 3. You do need to simplify that. Don't leave it as a fraction on the bottom. When it comes to number 13, you do need to look at that picture. First off, I know it's a cosine function. I'm just going to show you this picture here. I know it's a cosine function because it starts at a high point. Okay, I also know it's a positive amplitude because it starts up at 4. So I know that when I write this, I'm going to have 4 cosine, and then I need something with the x, so I need something with the theta. Well, if I look, it starts here, and it ends here. Well, this is 1 pi, 2 pi, 3 pi, 4 pi. So the period is where it starts and stops. So it starts and stops, so this would be at 4 pi. So when I'm figuring out my equation, I'm going to use the period equation and set it equal to 4 pi. So if I do like I've been doing, I get 2 pi equals 4 pi times b. Divide by 4 pi. Pi's cancel, so I get 1/2 is my b, and that's what I'm going to put over here with my x. So my equation is that guy right there. When it comes to number, now technically on your review, it's numbered 13 and 14, but it somehow got off when I numbered them. So they are technically numbers 14 and 15. You are going to be given one that is a sine function. You're going to be given one that is a cosine function. Remember, when you go to graph these, I have to fill the entire graph. You need to know the amplitude and you have to know the period. So on this one, the amplitude would be 2. The period would be 2 pi over b. But b in this case, because the 2 is on the bottom, remember that that's the same thing as writing it as 1/2 times x. So your b would be 1/2, which means your period is 4 pi. Okay, so when we go to graph a sine curve, remember you start at 0, and then you go wherever your period is, and that's where you're going to put your ending dot. Remember, the first dot and the last dot should be on the same level. Then you go halfway in between those, and you're going to put a dot at 0. Sine graphs kind of make the roller coaster, so they're going to go up and then down, or go down and then up. So then what I do is go halfway in between these two dots. Since my amplitude is a positive 2, I'm going to go up to 2 and I'm going to put a dot. Halfway in between 2 and 4, at 3, I'm going to go down to 2 and put a dot. And I'm going to draw my curve. I missed a dot. But remember, you also have to do it on the opposite side. So I'm going to have a dot at negative 2 pi. And for this to make sense, I need to go down rather than up. Remember, it has to make a continuous curve. So that would be my entire graph. When you get down here to this very last one, this is going to be your cosine function. On this one, the amplitude is going to be 1/2. The period would be 2 pi over b. Well, b in this case is just 2. So the period is just pi. You are going to most likely get one that is smaller, and you're going to get one that's a little bit bigger. So kind of be prepared for that. Cosine, I didn't label these, so you can label them whatever you want. I'm going to put a -1/2 here and a 1/2 here just so I have a little more space. This one, to start off with, it's negative in the original, so I need to start down at a -1/2. My period is pi, so at pi I'm also going to be down at a -1/2. I'm then going to go halfway in between those two. And this is roughly an estimation, and you're going to go up to a 1/2. You then go halfway, and your graphs are a little bit bigger than mine, and you'll have a dot at 0 and 0. And you draw your curve. And then you just continue your pattern. So at pi and then 2 pi, halfway in between you go up, then you're at 0 and 0 at halfway in between those. So it's a lot of halves, and you're just going to continue that pattern until you filled the entire graph. You don't have to label points. You don't have to do anything like that. And then you're going to go backwards. So when you go backwards on cosine, Your dots are actually going to be in the exact same place they were when you went the positive direction. And you just fill it until it's completely full. So this one should have a lot of little bumps. Now, like I said, yours is a little more spread out, so you can actually see where these 0 dots are going to go a little easier. But you will have one where they're a little bit smaller. Make sure you understand how to do cosine and sine, but you're not going to be asked to label points or anything like that. It's going to be basically following the pattern. So make sure that you look through your review, answer any questions that you have. If you still have questions, please come in and see me tomorrow.